In this video, I'm going to kind of walk through and talk about how we can use a spreadsheet to assess normality, which is going to be the main thing we look at in this unit. So what we're going to do here is go through and calculate a bunch of stuff and figure out whether we think this data is normal or not. So you'll notice our data set here is the length of a great white shark. So there's a bunch of these data points that were collected, and we want to assess, is this data normal or not? Can we use a normal distribution to describe it? So the first thing that we want to do is try and test, use a histogram. So what I'm going to do is highlight this, and I'm going to insert a histogram. You've already seen this before, hopefully, so I'm not going to talk a whole lot about it. So this is a histogram, and let's make these a little bit better. So I'm going to change the buckets a bit and go with, say, values of 2. Yeah, that looks pretty good. So again, we're just eyeballing it. So if I look at this, it doesn't immediately jump out to me as like, I should not use this, right? Because it does look pretty normal. There is this skew a bit to the left if we look at the values, but it doesn't look terrible. And so what I'm going to do here is I'm going to run some calculations. So we want to test the empirical rule, or the, the 68, 95, 99.7, which you can see this is what we would expect on a normal distribution. So we're going to do the average of, let's see, that's going to be B2. And if you type B like a range and you do a value, colon, and then just that same column, or a column value, it'll go all the way to the bottom or to the end. So that way I don't have to know exactly where it ends, as long as I know nothing below it. There's going to be nothing below it that it might pick up. I can do that, and then I don't want to highlight that. So we see that our mean here is like 15.6. We can do the same thing for standard deviation. So stdev, and that will again be B2 through the end of B. And that's our standard deviation. So now what I want to do is count how many are within each of these things. So this is going to be equal to count if. And so we're going to talk about the count if function, but we're actually going to do the count ifs, because that lets us put in multiple criteria. So I'm still going to do B2 through the end of B. And then I can put in the first criteria. So I want it to be if it is less than what I'm going to type in here next. And then because I want to type in a formula here, I have to put in the ampersand. So I set less than to say I want to look for values that are less than what I'm going to type in here. And then I type and to say I want to look at values less than what I'm going to type after this. F2 plus G2. So that's going to look for values that are less than one standard deviation above the mean. And then I'm also going to say they also have to be less or greater than, so again, I put the same range in, they also have to be greater than F2 minus G2. So you can pause, copy that in if you're following along. So again, we have the, first we put our range, like the cells that we're looking at, B2 through the end of the column. Then before, if you used count if, you might have just did like less than 10 or less than 5. But I want to say less than a formula, so I don't have to type in those numbers manually. If you want to calculate that, you're more than welcome to. So you could do that and then type in less than whatever the number should be, greater than whatever the number should be. But because I did count ifs, I can put in multiple criteria. And I can look for all the numbers that are in this range that are less than this value, and within that range and greater than that value. And if I hit enter, I get a number of 30. So now I've already done the next two, so I'm just going to copy those formulas over, and then we can talk about them. So if you look here, you see that it's the same formula, but now I've put in 2 standard deviations. Same formula, but I've put in 3 standard deviations. And then we'll undo that to fix it back. And now if I want to find that percentage, well, we know that there are, if we look down here, I go to 45. I don't have any in the first data, so I've got 44 total values. So it's going to be equals this divided by 44. And then this tells me how many values are within that many standard deviations. And we see that we get 68.1, 95.4, 99.7. So actually, if we just look at our empirical rule, these are pretty close. So we'd say, like, this looks pretty normal. It would probably be fair to say we can use a normal distribution. We just realized that, again, when we look back at our data, the data is slightly skewed to the left, and that might be something you need to just be aware of going forward. Let's look at now using the other technique. So that all that we've done is just using histograms and the empirical rule to say, yeah, it's probably pretty normal. Now we're going to use a probability density curve. And that's where I've got this other stuff kind of already in place. So the first thing I'm going to do is I need to sort my data by, sort it by value. So I've highlighted all of it. And then I'm going to sort, can I do that from here? No, I've got to go to data. Data, and I'm going to choose sort range by the column, and I can go from A to Z or Z to A. So A to Z is small to large, alphabetical. Z to A is the opposite. So A to Z, we see I start with 9.4, end with 22.8. If I change it to Z to A, it goes the opposite direction. So we want it to go low to big, right? So data, sort range, A to Z. If you accidentally see that your whole sheet changed, that was because you selected sort sheet. So just undo and then go back and you can fix that. Now we need to label all these positions for a reason that will make sense in a second. So I'm going to type the first 3, and something that's neat here is if you have a pattern that the computer can easily pick up on, so for example 1, 2, 3, if you highlight that and then this little dot here, well, you'll notice my crosshair becomes the plus. So not where it's the hand, but where it's that little plus. I can drag that down and it will continue the pattern, and you'll see it fills in all those numbers. This works for patterns of just data that's in there. It also works for formulas sometimes. So if you feel like the computer can figure it out, give it a shot and see what happens. Now for the percentile, we know that the percentile is going to be the number of data points that are equal to or less than this point. So in other words, it's just the position divided by the total. So this should be equal to the position divided by the total. And then it suggests we autofill it, so we're going to hit enter. It didn't work, so I'll just show you that trick again. Go to the corner where it's the dot, because that's going to be the fill down. Drag down, and we fill it in. So let's just check a couple things to see if they make sense, make sure this looks right. So the first one should be about 2%. That seems reasonable because 1 divided by 44 should be about 2. The last one is 1, which is what we'd expect because 100% of the data is equal to or less than the top position. And then at 22, that's halfway in between, and we're at the 50th percentile. Okay, so those all look good. Now what we need to do is calculate the z-score. Actually, let's pause. Sorry, I realized I want to do something else here. So we're going to take a step back. We're going to hit pause on what we've done so far. Let's calculate all of our z-scores. This might be useful to you kind of going forward. So if we want to calculate our z-score, remember z-score is always going to be the value minus the mean divided by the standard deviation. So B2 minus F2 divided by G2. And I need those parentheses in there so I make sure I divide properly and I don't just divide F2 by G2. So I get a z-score of -2.26, etc. Now, if I use that trick that I was showing you earlier of clicking and dragging through, we get a lot of stuff that's making a mess. So it got confused. Well, let's look at what it did instead. And we see that the problem here is it took B3, which we wanted it to, but then it subtracted F3, which has no value, and G3, which has no value, and so we ended up dividing by 0. So if you want to reference a specific cell, because again, when we copy paste, it looks at like, oh, 1 cell to the left, 2 to the right, 3 to the right. If we want to copy an exact function or reference a specific cell, what we're going to do is put a $sign in front of the thing we want to reference specifically. So in this case, we always want to be looking at the second row for F2 and G2. So I put 1 in front of the 2 and in front of the 2 here. If I put it in front of the F and in front of the G, that's not going to break anything because then it's just saying look exactly in F and exactly in G. So if I had multiple columns of data, this could all refer to the same place. I'm going to leave them out just for now because they aren't necessary. So my value didn't change because I didn't change any of the things there. But if I drag this through, hopefully it works this time. And that does look pretty reasonable. So we see that now we get a bunch of z-scores. How do we check to see if they appear to be correct or not? Well, let's look at the mean is 15.5. That means it should have a z-score of about 0. So do I have any data points at 15.5? No, but I do have a data point at 15.3 and 15.7, and we see that it does go from negative to positive, so this seems correct as far as calculating it. Likewise, if I go up by 2.5 from 15.5, that's going to be about 18. What are my 18s? Those are right about at 1. So it seems good. So now we want to calculate, I'll pause there. If you have any questions, let me know. But what we've done so far is we've calculated percentiles, and that's just the position of the percentiles have nothing to do with the z-score yet. We calculated the z-score because then we can compare it to normal values here. In order to calculate the normal distribution z-scores, though, we need the percentiles. So what we're going to do here is use a formula. And this is a lookup, so it's going to be equal to the normal distribution, and it's the standard normal distribution, and we want to invert it because we want to get a z-score from a percentile. So that's what this function means. And if you click on this, you can see it returns the value of the inverse standard normal distribution for a specified value. So if I put in a percentile, this will give me a z-score. If I just did norm s and then I put in values, they would give me the percentiles. So I want to work backwards from that. This is just looking up on a table in a fancy way. So then I want to look at, in this case, C2, because we want to take the percentile and convert it back to a z-score. And we see that we get the z-score there. And I drag this down. So let's check if these make sense. So if I start with 9.4, that's about 2.5 is about 10. So if we look, going back, percentiles. 2%, if you look that up on the table, you'd expect to see about 0 as your z-score. We know that our z-score of -1 should be right around, what is that, 30-something%, z-score of -1. So we should have a -1. Sorry, it's at 12%, that's right, because it's 15 on either side. At our mean, we have a z-score of 0, and that's what we have going through here. So now our standard probability, or our normal probability plot, I want to go and insert a chart. And this gives us a bunch of random stuff. So we're actually going to go to Setup And you can't see that, so let's shift over just a little bit. So now you should be able to see my settings. Great. So we're going to change this to a scatter plot. And then our x-axis is going to be, from here, we want our x-axis to be our values. So I'm going to highlight the values 9.4 to 22.8 and hit OK. Then my series, that's my y values. I'm going to select my z scores like this. We see we've got a number. And actually, I'm going to take out this last one just because it doesn't like handling the 100th percentile. And then what we have here is we can go in and label these. This is my length in feet. So I'm putting that over here. And then my vertical axis, if I want to go to the label, vertical axis, this is my z-score. And then it's not a histogram of position. It is the normal probability plot for shark lengths. And if we look at this here, again, for these we're looking for roughly diagonal straight lines. And if we look at this, this is pretty roughly a diagonal straight line. Certainly once we get past the initial values, we see a very nice straight line here. We'll talk more about this in a later unit, but we can throw in a trend line just to see here. And then if I add my label, use equation, and then I use r squared, basically the closer this r is to 1, the more you can say that this is described by the equation. And because I put in a linear line, an r squared value of 98 means this is a pretty good fit. It's quite close to 1. You'd want to see something like a 98, 99, something like that, 99.9, something along those lines. It's not perfect though, especially on this low end. You see this outline and all of that. The last thing I'll mention, it doesn't matter which thing is on which axis. If I switched these two, which I'll do just quickly here. So I'll set my, whoops. Well, I won't worry about that. But if I switch them, it would look slightly different, but it would still should be roughly a diagonal line. So that's how we create a normal probability plot. Let me know what questions you have. Otherwise, I'm going to wrap up here for now.